Hello, algebra students, Mr. Lawrence here, and we are going to do two more types of problems today. Okay, the first is going to be graphing absolute value functions. Now, you should know that these make a V, right? It's going to be V-shaped, okay? And in the V, there's an important point. It's down here, right? It's called the vertex. It's like the point of the V. Now, to find the vertex, pay attention to this. You don't just change signs. You look for what number x, what value of x, causes this x minus 5 to become 0. So, to find the vertex, the x coordinate is going to be whatever makes this 0. Well, I think if x minus 5 equals 0, and I solve that for x, I'm going to get 5. Therefore, my x coordinate is 5. Now, the y coordinate is simple. Don't go getting all crazy, doing a bunch of stuff for the sake of doing it. This is not the y-intercept. Instead, it's the y coordinate of the vertex. So, the vertex for this graph is at the point 5, 1. 5, 1, right there. Okay, now, the only other thing you need to know is the slope. And the slope is found looking right here, right in front of the absolute value, just kind of like m is in mx plus b, right? This one's in front of the absolute value. There's my slope. Now, one thing you have to remember is that these graphs will all be symmetric, right? They'll all have symmetry. So, I am going to plot a couple of points using the slope. And then I'm going to use symmetry to plot the other points. So I go to my vertex. Oop, where did my mouse go? Mouse, there you are. And my slope is 2 as a fraction 2 over 1. So I'm going to rise 2, run 1. I'm going to rise 2, run 1. Now I know this is the bottom of the V. And since there's symmetry, if I rise 2 and ran 1, I'm also going to rise 2 and go back 1. Rise 2 and go back 1. And look, it's perfectly symmetrical. And then I'll draw my graph like this. Okay. Just like that. There you go. Bam. This is too easy, ladies and gentlemen. You know, I was talking to somebody who was telling me how nervous they get during a test. And I'll tell you what can cure your nerves. Preparation. I know too many of you didn't prepare enough. You prepared a little bit, but you didn't really memorize the stuff you needed to memorize. Well, do a little extra preparation. Get into Math Excel, do some of the study guides, right? Okay, so let's go here and let's find the vertex. Step 1, find the vertex. All right, so I'm going to find the vertex. So the x coordinate is found by turning this to 0. Doesn't make it 0, it's x plus 3 equals 0. Solve for x, and x is going to equal negative 3. And then test it, negative 3 plus 3, sure enough that's 0. So I'm going to put negative 3 for my x coordinate. My y coordinate is here. It looks like a y-intercept, it's just the y coordinate of the vertex. So this one will go negative 3, 1, 2, 3, and then negative 4, 1, 2, 3, 4. All right, my slope is here. So I'm going to rise negative 2 and run 1, 2, 3. Rise negative 2 and run 1, 2, 3. Now, because of symmetry, I'll go back to my vertex, and since I went down to right 3, I'll go down to left 3. And then from there, down 2 and left 1, 2, 3. And there you go. These problems, you should pray I give you 10 of them because they are so bloody simple. Now, I don't know if you notice this V is opening downward. The other V was opening upward. What's the difference? I'll bet you Bryce can tell me. It's because the slope on this particular graph, where's my highlighter? This slope was negative, right? But on the previous problem, the slope was positive. So it opened upward. Okay, so I want you to try this one on your own. Pause the video, see what you can do. All right, here we go. First, I find my vertex. So let's see, x plus 2 equals 0. Solving for x, I get x is negative 2. That means the x-coordinate of my vertex is at negative 2. The y-coordinate is positive 3. So I'm going to go 2 to the left, and then up 1, 2, 3 right there. There we go. I should put my origin in there. All right, now my slope is sitting right here. What number is there? Well, how many x's do you see right here? I see 1. I see 1x. Yep. How many pentagons do you see now? I see 1. Uh-oh. That was strange. Okay, so I see 1 pentagon. How many absolute values do you see? Well, I see 1. So my slope is 1 over 1. So I'm going to rise 1, run 1, rise 1, run 1. But then because of symmetry, if I went up 1, right 1, I have to go up 1, left 1, up 1, left 1. And I am going to draw my absolute value graph. Go ahead. Quickly. Oh, my son doesn't want to say anything today. He was a big hit yesterday, but he's gotten stage fright today. All right, now there's one more type of problem I want to talk about, and that's these equations. Too many of you are getting them wrong. I suggest that you make a flashcard for each of these. Now, I've memorized one of them, and remember, the other one has to be the opposite. So, let's check this out here. In this blue equation, or excuse me, the black equation, how many x's do you see? Well, I see 0. Can you rewrite this equation so that you can see the 0 x's? Try it. Okay, I'm going to write it so that there are 0 x's. Y equals 0x plus 4, right? The 4 is positive. So now, what's my slope? Well, you should know, and you know, the past couple of days I've heard a couple of people say 0 over 0. If you said that, please get up and do 5 push-ups right now. We're going to put this 0 over 1. That's how we find our slope, right? We put the number over 1. We don't put it over 0 ever. We never divide by 0. Okay, so I'm going to plot the y-intercept, which is going to be at 0, 4. So it's right there. And then from there, I'm going to rise 0, run 1. Rise 0, run 1. What type of line did I get? Sure enough, I got a horizontal line. Anytime you see an equation, y equal to just some plain old number, it is a horizontal line. James, I'm almost done, buddy. Okay, so I'm just putting an arrowhead on here. Now, if y equals 0 is a horizontal line, and you should memorize that, I guarantee you will see it on the test again. What kind of line do you think x equals 5 is? Well, I'm not going to tell you. Hopefully, you've already said the right answer. But what I'm going to do is I'm going to make an input-output table. Okay, now, did I mention the equation is x equals 5? Right? X equals 5. Did you hear that? X equals 5. Dan, what's x? Yeah, it's 5. So when I go to fill in my input-output table, I'm going to put 5 in for x. Now, what's y? How about 2? Sure, y can be 2. So I'm going to plot the point 5, 2. Now I need another point. Okay? And what does x have to be? What's that equation? It's 5. X equals 5. Now, to put 2 here would be ridiculous because we've already plotted that point. So we must have to have another value of x. How about 0? Oh, 5, 0. That would be this point right here. Look at this. What kind of line am I getting? How about 5, negative 3? because the lines go on forever. The y-coordinate can be anything. Some of you are going, well, why can't the x-coordinate be anything? Because x equals 5. It says so right here. X is 5. What's x? 5 every single time. So this is going to be a vertical line. And so I'm going to draw a vertical line like this, and I'll change the color of it. Okay, now this is true no matter what the value is. So, property, let's make it red. Let's put an arrowhead, and there you go. All right, so you tell me, what kind of line is this? You better be saying vertical. How about this one? What kind of line is this? Horizontal. Absolutely. This is too easy, ladies and gentlemen. It's too easy. In the top one, x equals 2, name 3 points on it. How about 2, 1? How about 2, 4? And how about 2, 8? Yep. How do I know those are all on the line? Because the equation says x equals 2. Look at my x coordinates. They're all 2. This one here, 3 points on the line. How about 0, -7? How about 5, -7? How about -6, -7? How did I get that? Because y equals -7 every single time. All right, so Thursday's the big day. Some of you get a chance to earn some points back and take the sting out of this test. And I'm wishing you well. But preparation is the key. Prepare. Do your best. All right, Mr. Lawrence signing off. Have a good night, everybody.